Good day. My name is Dexter Melton. This is the CS-499 Initial Code Review. This video is going to be covering my initial artifact, the weaknesses and limitations of that artifact going off the code review checklist provided, and the enhancement plan across the three categories that you see listed: software engineering and design, algorithms and data structures, as well as databases. So let's take a look at the initial one. Okay, so this is my initial artifact. It is a text-based adventure game written in Python. The goal is to move around the map, pick up all 6 items before you stumble into the dungeon. If you get into the dungeon before you have the 6 items, you'll lose. I developed this in my early time at Southern New Hampshire University. It works, but it could be a lot more. So let's take a look at it. The core structures are, you see at the top, there's a command list that has valid user input commands. There's a graph. This lays out the rooms, um, how they connect their navigation options, and whatever items they contain, if they contain items. And then finally, there's a set that holds all of the items that can be picked up during the game. So, moving into the actual game logic, we start with the main menu function. This has quick little prompts just outlining the goals of the game for the user, and then a basic menu of options. So, throughout the entire game, anytime a user inputs a command, it is compared to the command list. If it doesn't match, it's considered an invalid choice and they are prompted to try again. Also, all of the inputs are converted to lowercase to minimize any potential errors in validation, incorrect capitalization, etc. Okay, so once the user actually begins to start the game, they are placed in the Great Hall with an empty inventory. And then they are told where they are and given direction to start looking for the items. So then they can start inputting commands, navigating around the game, attempting to find all the items before the dungeon. At any point during the game, the user can either quit to exit the game, or they can type in help, which will give them the valid command list in case they forgot it. Now, and again, you can see if they try and navigate the wrong way, they'll get a prompt saying that's invalid. If they put in the wrong commands, it'll be invalid. And then right here, you see the two lower, which is converting their commands to lowercase. So at any point in the game, when a user enters a room that has an item, they are prompted to choose whether or not they want to pick it up. If they choose yes, it will be added to their inventory, and then they are shown the inventory with the item in it. If they choose no, they just leave it. And then at any point during the game, if they want to view their inventory, they just have to type inventory. It'll show them their progress of finding the 6 items, as well as what items they actually have. So moving on from there, once they actually get to the dungeon, it will take what they have, their inventory, and it will compare it to all the items, the all items set, that is. If they have them all, then they win. If not, then they'll die. Whether or not win or lose, this will cycle and it will trigger the main menu function again, and they will be brought back to this prompt where they have the options to begin again or quit, whichever the user chooses. So let's do a quick demo of this just to see how it works. Okay, so as you see, here's a prompt, here's the menu, and you can see there's some formatting issues over here on the side. It's not as clean as it could be. And that was just me not knowing how to do the spacing and everything back then. So We can view the list of the commands real quick. You can see northeast, southwest, inventory, help. And so let's see, let's start the game. So as you see, we are in the Great Hall. If we view our inventory is empty. So let's go find an item to pick up. All right, we see a shield. We pick it up, and then it displays our inventory with our item. And then for the sake of brevity, we'll just go and trigger the dungeon. So you can see we lost. It brings us back to the menu. Here's our choices. And as you see, it's kind of like wham, bam, like there's no time spacing or anything like that. It just keeps scrolling super fast, which is something that obviously I didn't know how to address back then. So, and then we'll just quit this. So overall, the game worked, but it is extremely simple. There's really nothing here that like stands out, no showcasing of any particular skill. And in addition, there are a lot of errors and limitations in it. So first off, it's all in one file. The state, logic, UI, they're all mixed together. There's no separation into modules or classes. And if I wanted to scale this to a graphic user interface or a new platform, it'd be much harder than as opposed to something that was actually separated in that way. The coding standards, it's consistent, but I didn't use any type hints or any type of format tooling or anything. It's all just kind of there, as you can see. There's limited duplication. I did do good at that, but like I said, the UI and the logic are mixed in ways that if you wanted to reuse pieces of this, there would most likely be complications. There is a good use of symbolic collections, the command list, the rooms, the items, but I don't leverage graphs or anything or use these to their fullest ability, and a lot of it's hard coded still. Obviously, the item names, the room names, they're all stuck in there, and these could be removed and centralized as constants or enumerations or something like that. There's zero documentation that goes along with this game. There's some minimal comments, but for the most part, the intent is largely implied by the names of the functions and the variables. And this is something that's going to be corrected going forward as the enhancements will have better commenting, more clear walkthrough, and documentation that goes along with it, how this game works, how it runs, etc. For variables and types, obviously, all of this is pretty much dynamic typing, which is fine. It works here, but it's definitely more of a junior programmer attempt, and the type hints would have made this readability a lot better. For loops and branches, the loops work, they're straightforward. There's some input guards against the unknown commands, but there's nothing really complex or branching. There's nothing that makes this stand out from a programming perspective. And along with that, looking at this from like a defensive programming standpoint, beyond that basic input validation, there's no error handling, there's no try catch, there's no security functions. And if this moved into a production setting or I attempted to expand this multiplayer style or web use, there would be problems along the way with that. So overall, like I said, it works. It's pretty good for when I did it, but I think we can take this way farther and do way more with it nowadays. So now that we've looked at the current code and its structure, I'm going to move into my enhancement plan, starting with software design and architecture. So for this enhancement, I am going to be porting this artifact over to C#. It will have a graphic user interface with WPF, and it's going to be built in the model view model or MVVM architecture. I'm gonna separate the concerns into models with classes and services, views for the screens, and then view models as the go-between for some separation. So as you can see here, the model layer is going to hold the room game data and logic. The room class will have information like items contained, descriptions, and the connections to the rooms. The item class is going to hold the item names and descriptions. The player class is going to track current room, inventory list, move count. And then those services, the game service will host movement validation, room transitions, win-loss resolution. The score service is going to handle the scoring, computing the actual final score of the player. And then database service is going to handle player data, score storage, stuff like that. Each service and model class is going to include unit testing to validate the game logic, scoring, and the goal is to improve the maintainability and reliability of this application. So the view model is going to host the application logic. These are the commands for starting the game, viewing the leaderboard, as well as executing the commands that will invoke the corresponding services in the model layer. And then finally, the view layer obviously is the user interface presentation portion. It's going to display the clickable buttons. It'll have an on-screen inventory. It'll show game stats such as number of moves, current location, as well as a leaderboard view with high scores. And these enhancements are going to take the artifact from a text-based terminal game into a graphic adventure. And it's going to have encapsulation, scalability, more engaging interfaces. And this architecture separates the UI from the logic, which means in the future, we can change the presentation layer without breaking the gameplay mechanics in the background. And while porting this to WPF introduces platform specificity, the benefit is MVVM testability and a richer user experience. Okay, so moving from that, we're going to look at some algorithm enhancements. So right now, the game has no algorithms implemented. The maps hard-coded, the items are hard-coded. They appear in the same location every time. There's no mapping optimization. There's nothing. So sky's the limit here. The goal of this enhancement is to make the game more exciting, dynamic by having the items populate in random rooms. And I'm going to introduce a scoring function where the user competes to find the shortest possible path each time. But to do that, the program is going to have to calculate the optimal route for comparison to the users. And this will be done with a two-stage algorithm. On the slide, you'll see a small flow diagram of the algorithm processes and how they connect. And so stage one is going to be a breadth first search, which will calculate the shortest distance between start, each item room, and dungeon. Stage two will be a held carp algorithm, and this algorithm will use the outcomes of the breadth first search and calculate the shortest path to grab all of the items and reach the dungeon. Now, held carp is an exponential algorithm, but we're capping the items at 6, so the runtime is still going to be extremely low, and using the breadth first pre-computation makes the dynamic programming inputs small. So after these two stages are implemented, it will require some thorough testing, logging the optimal route, player moves, and delta to confirm correctness. We're also going to be comparing the computed optimal route to manual small map solutions to confirm the dynamic programming's implementation. Just make sure everything's working, because at the end of this will be the real heart of the game logic, is competing against the shortest path possible. And so once this algorithm is in place, tested working, we can implement the scoring structure. So each item is going to be worth points, but for every move over the optimal move count, the player will begin to lose points. And this new scoring functionality will really shape the gameplay into something with more purpose. Because right now the text-based game works, but you do it one time, you solve it one time and you're good. This one will be dynamic. You just never know what you're going to run into. You're always going to be able to try and beat your scores. So that will this will enhance the application immensely by introducing some algorithms and optimization in here. And finally, we come to the database enhancements. And this will be a big change to the existing program because as of right now, there is no database. There is no persistency. Nothing is carried from one game to the next. And as I said before, I built this very early on, so I didn't really understand the concepts of mounting databases, storing scores, storing profiles. And so right now, the game works, but it's a little pointless. And we're going to try and change that. So the plan is we're going to add SQLite via Entity Framework Core for player profiles and scores. And we're not going to get kind of crazy here. As you can see, it's rather simple. There will be two tables. One's going to hold the player's name, and one's going to hold the score, the player ID, the score, the moves, counts, etc. And the flow is also on the simpler side. When the game ends, it'll compute the final score and it's going to insert that into the database. And then when users go to the leaderboard view, it's going to pull the player names and their corresponding scores out of the database and list them. Nothing too crazy, but still a big jump from where the program was to where it's going to be. Along with this database implementation, there's going to be some data integrity. I'm going to build in basic input sanitation, some try catch blocks to handle database connection errors. And what this will do is it also gives it some possibility of extension. This could be easily scaled to a remote SQL server or something cloud based with minimal code changes, just telling it a different database to point at, essentially. I haven't decided yet if I'm going to have users select their profile in the beginning or if I'm going to lean more towards the arcade style where they get to the end and then they input their initials for high scores. But either way, having this will allow the player to keep track of scores and actually compete with other players or themselves for high scores. And having this persistency and being able to see old scores and progress, I feel will really round out the application to make it feel like an actual game as opposed to what it is now. So this brings me to the end of my enhancement plan. As you can see, there's major updates to the entire application. The next steps are to set up a C# project, implement the base models and services, and just begin porting the game logic incrementally. And by the end of this, we should be able to transform this text-based terminal game into what is essentially a full stack application. Again, my name is Dexter Melton. This is for CS-499 Capstone. Thank you for watching, and I hope you enjoyed the video.